This is section 6.6, day 2. You throw a ball with a speed of 38 miles per hour at an angle of 42 degrees. Express the vector in terms of I and j. Let's get it in component form. We have 38 cosine of 42 degrees and 38 sine of 42 degrees. So let's get this on the calculator. I'm going to make sure our calculator is in degrees. It is. We have 38 cosine of 42 and then 38 sine of 42. So the component form is, with these two numbers, and then we can go right to I and j with this, and we can write 28.24i plus 25.43j. Two tractors are tugging on a stump. Find the overall force and direction being exerted on the stump. So we have a tractor pulling on the stump this way at 28 degrees and exerting 60 newtons of force. Another tractor is pulling this way, where this right here is the 4 degrees, this is the 28 degrees, and this has 80 newtons of force, and this is tractor 2. So we want to see what the overall force is and the path of the force exerted on the stump. So we're going to take one of these vectors and we're going to go end to end. So we're going to take this one down here, tractor number 2, and we're going to put it up here like that. And so the resulting force and the resulting angle is from the very beginning to the very end like that. And so we want to get this resulting vector. We're going to take 60 cosine of 28 degrees and 60 sine of 28 degrees, and that is going to get the component form of this vector right there. And then we need the component form of the tractor 2 vector that we put up here on top of the first one. And that's going to be 80, and it's going to be cosine of, now we're using unit circle measurements, and yeah, this is really negative 4 degrees, but if we go all the way around, it's 356 degrees. So cosine of 356 and 80 sine of 356. Now we want the component form of the resulting vector, so we're going to add these two together. We got 60 cosine of 28 plus 80 cosine of 356. And that is 132 I'll just write 782 here, but we're going to use this entire number. We're going to go grab this number here in a second. So let's get the y component. So we have 60 sine of 28 and plus 80 sine of 356. And that's 22.5877, keep on going. So now we have the y component and the x component, and we want to find the overall force, because that's like the magnitude of the resulting vector. So we're going to use Pythagorean theorem. So we want square root of 132.782 squared plus 22.587 squared. And let's do the square root of, and let's go grab this number up here. We're going to grab that number and square it, plus, and then we can go up and grab the 22 one right here. We're going to grab that and square it, press enter. And so the overall force on the stump is 134.69 newtons. And then we'll take the inverse tangent of the 22.587 divided by the 132.782. But we're going to actually go grab the numbers. So we're going to do second inverse tangent. I need the 22. And we're going to divide that by, we'll go grab the 132 up here. And the angle, the overall angle is 9.65 degrees. A plane is traveling 300 miles per hour at a bearing of north 50 degrees east. So this plane is going northeast. And so we have 50 degrees like this. And we're going to make this 300 miles per hour. So this is 300. But we really want, this is the 50 right here. Here's the 50. But we want the unit circle measurement. So what we really want is 40. And then we have a 40 mile per hour wind is blowing at a bearing of north 60 degrees west. So it's like we have this brand new XY axis, 60 degrees northwest. So we're going to go like that right there. And let's call this length 40. This right here is the 60 from north 60 degrees on the west side. Now the resulting vector, we want to know, find the resulting speed and direction bearing of the plane. So we want this vector right there. So we're going to do vector addition with this. So we have the 300. This actually should be 300. We got the 40. So the 300 is with the 40 degrees. So the plane's vector is 300 cosine of 40 and 300 sine of 40. And we'll get this, the component form of the plane. Then we have the wind. The wind is 40 cosine of, well, this is the 60 degrees from the bearing right there. And it's on the west side of north, but we need the unit circle measurement. So we need 90 plus another 60. That's 150. And we have 40 sine of 150. All right, so let's get the resulting component form. We got 300 cosine of 40 plus 40 cosine of 150. And that is 195 and some change. So the resulting, the path, let's say the path is 195.172. But we're going to go grab those numbers. And then we have 300 sine of 40 plus 40 sine of 150. And that's 212. So 212.836. Well, now we want the resulting speed. We want the magnitude. So the magnitude of the path is equal to the square root of 195.172 squared. But we're not going to use the rounded form. We have 212.836 squared. We're going to go grab the actual number. So let's go square root of, I need the 195, and we're going to square that, plus, let's go grab the 212, square that. And so the resulting speed is 288.78, and we got miles per hour. And then they want the resulting speed and direction bearing. All right, so we're going to do inverse tangent of the 212 of y over x, 836 over 195.172. And we're going to use the actual numbers. We're not going to use the rounded numbers. Inverse tangent of, we need the 212. So there's a 212. And divided by, we need the 195. That's up there. Now, the unit circle angle is 47.4789. Keep on going. And that angle is right here. Here's the red is the resulting vector. So this right here is the 47. Now, this plane is heading northeast. So northeast, but we need the angle not from the east, but we need the angle from the north side. So we're going to take 90. We're going to minus this number right here, and we get 42.5 degrees. Here's the magnitude, and here's the direction bearing. A plane is traveling 260 miles per hour at a bearing of north 35 degrees east. So 35 degrees, that's more like 40. That's all right. It doesn't really matter how we draw these, as long as it's close. A 40 mile per hour wind is blowing from a bearing of north 50 degrees west. So let's go north 50 degrees west. That would be north 50 degrees west would be like this, but it's blowing from that direction. So it's actually going in the opposite direction like that. And so this is the 260 and this is the 40. So we want the resulting vector right here, like that. So let's do the plane. Let's get the component form of the plane. That's 260 times the cosine of, let's see, the blue, that was north 35 degrees. So this right here was 35 degrees, but we need the unit circle measurement. We need, 55? So cosine 55 degrees. And then 260 sine of 55 degrees. So there's the component form for the plane. The wind is 40. Cosine of, let's see, this 50 degrees, this right here was 50 degrees. And so that means that this right here is 50 degrees. But we need the unit circle measurement for that. And it's 50 degrees short of 270, really. So the wind is, 230. So 230 degrees and 40 sine of 230 degrees. So let's get the resulting vector. We have 260 cosine of 55 plus 40 cosine of 230. So 123. So the resulting path, let's say, is 123.418. And then 260 sine of 55 plus 40 sine of 230 is 182 let's go 337. So now we need the Pythagorean theorem. The magnitude of P is equal to the square root of the 123.418 squared plus 182.337 squared. So we'll go square root and we'll grab the 123, square that, plus go up to this one and square it. And there's the magnitude. So the speed of the plane is 220.18 miles per hour. And inverse tangent of 182.337 over 123.418. Let's find out what that is. Inverse tangent of the 182 divided by 123. And so the unit circle angle is 55.9 degrees, and that's to the red. So 55.9, but we want this one right there. We want the bearing. Now we know that this is going to the northeast, and we can take 90 minus this value, and we get 34.1. So let's go 34.1 degrees. Make sure you upload this exit ticket to Google Classroom.